Alright, this is 1.2 homework. I'll be going over problem 70, 73, 79, 81, 83. If you need me to articulate over anything, because I'll be going really fast, feel free to hit me up on Discord, and um, I will also leave the answers in the description if you don't want to sit through the whole video. So, number 70. If a sample containing 2 milliliters of nitroglycerin is detonated, how many total moles of the gas are produced? So, there's a lot of stuff that we need to do. First thing, we need to convert milliliters into grams, and we'll be using a conversion factor that's provided. So we see that 2 milliliters nitroglycerin, you can use the conversion factor 1.592 grams per milliliter, and that crosses out milliliters, and we're left with grams nitroglycerin. And then from there, we're going to have to convert to moles, so then we'll do times 1 mole, and we'll be using not the conversion factor, we'll be using the molar mass, which you can either calculate, or it'll be given, or you can just Google it, I don't know. Whatever situation you're in, find the molar mass. And then we'll do something kind of weird. We're going to find the amount of moles produced, not just the moles of carbon, not just the moles of nitrogen. We're going to find the moles of all of the gas, because that's what we're looking to find. We're trying to find how many total moles are produced. So we're trying to find all the products. And from this, we find that there are 29 moles of product. This is just found by adding up everything. 12 plus 6 plus 1 plus 10. 29 moles product. Because we're trying to find the amount of gas that's produced. So we'll be adding up all of the products, and then we'll be dividing by the reactants, which is just the nitroglycerin, and that'll give us our answer, which is 0.102 grams. Moles, sorry. 0.102 moles. And this answer is adjusted for sig fig, so it might look a little different for you. Alright, I'm going to write down B and C, and we'll go over those in a second. Alright, so question number 73. So, this is kind of a fun one. A manufactured bicycle has this many wheels, this many frames, and this many handlebars. How many bicycles can be made? So, all we need to do is figure out how many wheels per bike we need, how many frames, how many handlebars. Obviously, you need 2 wheels, 1 frame, and 1 handlebar. So, first thing I'm going to do is I'm going to divide wheels by 2, so we get a more equal amount, a more even playing field. And that will give me 2,407 wheels, just dividing by 2. And now we're going to see what is the lowest amount we have, because the lowest, you can't make, like for example, actually, yeah, for handlebars, we have the least amount of handlebars. And so we cannot make more than 2,255 handlebars, because what are you going to do? You can't summon into handlebars. So that is the least amount, and that is also called the limiting reagent, or the limiting reactant. Anyway, part B. How many parts of each kind are left over? All this is asking is just subtracting. So you'll have 0 handlebars left, because that's limiting. You will have 305 wheels. And this is all through subtraction, by the way. And you will have 50 frames. Now for C, which part limits the production of bicycles? It is the handlebars, because that's the thing that you have the least of. This is a concept that you'll be learning a lot more about in chemistry, the limiting reagent. So this is kind of a good example to keep in mind. You cannot make more bikes without a handlebar, if that's what helps you. So yeah, it's handlebar. Anyway, next problem. So this problem is quite a doozy. So I got the teacher's version of the textbook, which has a key for this problem out of so many. I was very lucky that it had one. Anyway, this problem is really heavy, so I just got this so it's easier to look at. So this problem is basically just saying that you have sodium carbonate and silver nitrate react to form silver carbonate and sodium nitrate, and it's saying how much do you have left after you have this much sodium nitrate and so blah 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 blah. So first thing you need to do is you need to make a balanced chemical equation. You should know how to do that already, but I'll go over it really quickly. You just need to get your sodium carbonate. Sodium carbonate, that's Na, and carbonate is CO3. You balance charges, same with silver nitrate, same with sodium nitrate, blah, blah, blah. And then with balancing, these kind of equations are very hard to balance. So I have a method in one of my other videos that you can use, or you could just use any method that works for you. You could use a table, whatever. But I get this is really difficult, so you please take your time on these. You're not expected to know these right off the bat. This would take me a long time to do. Anyway, Next thing you need to do is convert your grams of sodium carbonate and grams of silver nitrate to moles. So 3.5 grams, convert those to moles. 5 grams, convert those to moles. And then the problem with comparing those moles is that the moles aren't worth the same. Where if you look at the equation, 1 mole of sodium carbonate is worth twice as much as a mole of silver nitrate, because 1 mole of sodium makes 2 moles of silver. So you need twice as many moles of silver to match 1 mole of sodium. So that's what we're going to need to do when comparing them to find our limiting reactant, because we're finding a limiting reactant here. Because the limiting reactant decides how much product you make, because you can't make more bicycles with no handlebars. So see that? Yeah, that's a good analogy to use. Anyway, you're going to need to convert your moles of whatever to another thing. The textbook converts moles of silver to moles of sodium. That's what they do. They find that there are less moles of sodium needed. So then, therefore, we find that silver is the limiting reactant, and the limiting reactant is the thing that you base your reaction off of. So from here on out, we're going to be using 0.0294 moles of silver nitrate as our model of the reaction, the amount that we're going to be converting everything into. But also, it's important to realize that you need to kind of convert a lot of these values, like in this table right here, in this chart. And I'm sorry, this is like a lot. I can't believe this made this a homework problem, but I'm really trying to get through all of this. You're going to need to make sure that, you're subtracting your amount from, because you're consuming 0.0147 moles of sodium, but that amount consumed because you have an excess amount of sodium. The excess amount of sodium is still left over, so you have to record that. And that's what they do in this little table. They just subtract the amount that is consumed. And then in the products you're creating stuff, and since you have 0.0330 moles of sodium carbonate, you're going to want to add that into the other things. So for example, with the sodium nitrates, it's just you're adding it. But with the silver, since there's only 1 to 2, you're going to have half as much. And I know this is really confusing. I hope that the table can help explain it better than I can. But yeah, it's just you're subtracting the amount that you have with the silver and going from there. And then finally, you're going to just want to convert to grams, and that's all. So yeah, I know this problem was really hard, so if you need help, I totally understand. You can DM me on Discord about it. So yeah, next problem. All right, 81. When benzene reacts with bromine, bromobenzene, probably my favorite chemical name I've ever heard, bromobenzene, is created. And that is a very simple equation. It's just 1 to 1, makes life super easy. When 30 grams of benzene reacts with 65 grams of bromine, what is the theoretical yield? Theoretical yield is just the scientific, chemical, if every atom reacted perfectly, everything went exactly your way, which it never will, how would it end up? So, yeah. Anyway, so what we need to do first is find our limiting reactant. Our limiting reactant is the thing we have the least of. And since it's a 1-to-1 ratio, it's just whatever we have the least moles of, because a 1-to-1 ratio, just means that, you don't need to do any conversions. So we find that through our conversions, I converted benzene and, bromine. I find that benzene you have less of, so that's your limiting reactant, and you're going to be using benzene as your model for the reaction, because you're going to have excess bromine, which doesn't matter, because you can't make more bikes without more handlebars, because you have none left. Sorry, I'm going to keep using that until I die. Anyway. So you're going to want to convert moles of benzene to grams of bromobenzene. All you need to do is convert moles benzene to moles bromobenzene, and then find grams with that. And since it's a 1-to-1 ratio, all you need to do is multiply it by its molar mass, which is 157 grams, and you'll get your final answer, 60.3 grams of bromobenzene, my favorite chemical. Finally, for part B, if the actual yield of bromobenzene is 42.3 grams, what is the percentage yield? Basically just saying, if we actually did this reaction and we got 42.3 grams, what is the percentage yield? This is obviously less than what we thought we would get, but in comparison, how much is that? And we find that that is 70.1%. That is just 42. This is how you calculate your grades. It's just 42.3 divided by 60.3. That gives you your total amount. All right, next problem. Okay, this is another long one, but basically, it's 3 main steps, but let's just go over it. Number 83. Hydrogen sulfide is an impurity, natural gas that must be removed. This is the Claus method, blah, blah, blah. It's just a reaction. Under these conditions, the process gives 98% yield. And if you start with this amount of H2S and this amount of O2, how many grams would be produced, assuming 98% yield? So what we're going to need to do is we're going to need to find our limiting reactant so that we can find our reaction, like our minimum, what we will find our products out of, right? And then we're going to need to find our, I guess, theoretical yield. And then we're going to have to multiply that by 0.98% to remove that 2% because you're only getting 98%. So you'll find that, and that'll be your answer. So first thing we need to do is we need to find which one is limiting reactant. That is what I put on the top. So since I did that and I got 0.880 mole H2S and 1.56 mole O2, I didn't calculate the moles because if you look at the reaction, you see that you need twice as many moles of H2S than oxygen, and you already have so much more oxygen. It was obvious, and I didn't need to calculate it, but other than that, you should usually calculate it. But to make life easier, if it's something super obvious like that where, you know, like it's clear, you don't need to use the calculations, but usually you should. Anyway, I find that H2S is the limiting reactant, so we'll be using H2S, the amount of H2S, as our model for the rest of our reaction. So then I use simple stoichiometry. Sorry for handwriting. I just multiplied the moles of H2S by 1/8 to find the amount of moles of sulfur because that's what we're looking for. And then when I found our moles of sulfur, I multiplied by 256, which is the molar mass, to get our molar mass. Not molar mass, to get the grams. And that gives us our theoretical yield of 28.2 grams. It's like 28.2 something something. And then I multiplied that by 0.98. That signifies 98%. And I got 28 grams. And that is the final answer. And that's all. Enjoy your night.